class. Today we're going to go over polynomial and rational inequalities. Alright, so our approach today is we want to get all terms to one side of the inequality in factored form and 0 on the other side. Then we are going to identify values that make the factored form equal to 0. We will then use a table of signs to determine the desired interval. Okay, here's the first example. It says x minus 3 times x minus 2 is less than or equal to 0. We already have it in terms of a factored form on the left-hand side and a 0 on the right-hand side. So we're already set up with step 1. But now we need to identify values that make the factored form equal to 0. Okay, so if we looked at this and thought about it as an inequality where it equaled 0, all we would do to figure that out is we would take x minus 3 and we would set that equal to 0, and then we would take x minus 2 and we would set that equal to 0. And then we would find that if x equals 3 or if x equals 2, then I wind up in a situation where we have our factored form equal to 0, right? Now we want to use those two terms here that we just found to use a table of signs to determine the desired intervals for which the equation on the left-hand side is indeed less than or equal to 0. Okay, so here's what we're going to want to do. All right, so when we're looking at this particular interval here, 2 is our lowest number out of the 3, which means that the first interval we want to look at is negative infinity to 2. Then we want to look at 2 to 3. And then we want to look at the interval from 3 to infinity. Okay. Now, what we're essentially going to do is we're going to look at each of the terms in these orchestrated intervals that we found here. Okay, so if I picked any number between negative infinity and 2, and I were to plug that number into x minus 3, I'd have to ask myself, do I wind up with a positive or a negative? Okay, and any of the numbers in this interval work. So if you chose, say, 1, if you plugged 1 in for x here, 1 minus 3 would be negative 2. So you wind up with a term that is negative. Now, what about the second term, the x minus 2? What if I plugged in a number between negative infinity and 2 into this value? Would I get a negative value or a positive value? Well, if I plugged 1 or let's say even 0 into here, I would get 1 minus 2 would be negative 1. So I'd wind up with a negative value. Now, if we look back at our original equation here, we have this term times this term. So this term times this term, negative term times negative term, should result in a positive outcome. Is a positive outcome what we want overall? No, it's not. Positive outcome isn't what we want because we want it to be less than or equal to 0. Okay, so let's look on to the next interval, the interval from 2 to 3. Okay, if I plug any number between 2 and 3 in to x minus 3, do I get a positive number or a negative number? Well, you could just pick one like 2.5. 2.5 minus 3 gives you negative a half. So hey, it gives us a negative value. But what if I plugged it into x minus 2? So if I plug 2.5 into x minus 2, I'd get a positive 1/2, which would give me a negative number overall. Is negative where we want to be? Yes, it is. So this interval right here from 2 to 3 does satisfy this inequality. Let's check our final interval from 3 to infinity. Okay, so we need to look at numbers bigger than 3. So let's look at 4. You can look at 5, 6, 7, any number you want. But I'm going to look at 4. 4 minus 3 is a positive number. 4 minus 2 is a positive number. And a positive number times a positive number is a positive number. So really the only interval that satisfies this is the interval from 2 to 3. The only extra thing we have to be careful of here is this is an inequality with an equality symbol in it right here, right? Which means that it's also equal to 0. It's okay if it's equal to 0. When does it equal 0? It equals 0 at 3 and 2. So the final solution would have to be a bracket 2, comma 3, bracket, because it is okay if it's equal to 0 here. Okay, so it's only negative in the interval from 2 to 3, and it's okay if it equals 2 or 3 because it's okay for it to be equal to 0. Let's try another one. Let's look at this one. It says 3x squared minus 4x plus 1 is greater than 0. We want to get all terms to one side of the inequality in factored form. So we're doing okay here. We got it all to one side, but we need to put it in factored form. Well, if I factor this one, it should factor into a 3x minus 1 times an x minus 1. Okay? And that should be greater than 0. Now, we can step forward, right? And we can step forward and identify the values that make the factored form equal to 0. Well, one of them should be fairly easy because you have an x minus 1 that would be equal to 0. So one of them should be x equals 1. The other one you might have to do a little bit more work. That's the 3x minus 1 that would equal 0. Here that would mean x is equal to 1/3. Alright, so here's my two constraints that I'm going to work with. 1/3 and 1. Okay, now I'm always going to start with the smallest one. So I'm going to go negative infinity to the smallest value I just found, which is 1/3. Then I'm going to go 1/3 to 1. And then I'm going to go from 1 to infinity. Now I also have to set these up because it wasn't pre-factored. So I'm going to have to set up 3x minus 1 here. And I'm going to have to set up x minus 1 here. Okay. Now, we want to check both of these within these intervals. So anything between negative infinity and 1/3. Okay. I want to choose 0 because 0 lies in that interval. So 3 times 0 is 0 minus 1 gives me a negative answer here. So anything in that interval should turn a negative answer for 3x minus 1. Same thing here. 0 in for x gives me a negative answer. Hey, negative and a negative give me a positive. Easy enough. Let's look between 1/3 and 1. This one might be a little tougher. Maybe we look at 2/3. So if we looked at 2/3 and plugged 2/3 in for x, even if you wanted to write it out to the side, if I plug this in for x, 3 and 3 cancel out. I get 2 minus 1 is a positive number. If I plug 2/3 in here, 2/3 minus 1 gives me a negative number. Okay? Positive times a negative gives me a negative. All right, let's look at the last interval from 1 all the way to infinity. Let's look at what happens if we plug 2 in. If I plug 2 in here, 3 times 2 is 6. 6 minus 1 is a positive number. If I plug 2 in here, 2 minus 1 is a positive number. So I wind up with an overall positive number. Well, what did we want this to be? We wanted it to be positive. But we also wanted it to be strictly greater than 0. So no equal to's here. So both of these intervals, the lower one and the upper one, do work. But we got to keep in mind we can't use brackets here because it's not equal to 0 in this scenario. So it should be negative infinity to 1/3, comma or union, if you want to write it that way, 1 to infinity. Okay, and now we have our interval for example 2. Now, let's look at this one. We have x times x plus 7 times 3 minus x is less than 0. Okay, well we already have it in factored form over here on the left hand side and a 0 on the right hand side. Step 1's out of the way. Let's identify the zeros here. Well, x equals 0 is a 0, x plus 7 equals 0, and 3 minus x equals 0. This one tells us that x equals negative 7 would be a 0, so we have two of the zeros isolated. And then here, 3 equals x would be a 0, so we have all of our zeros isolated. So we can now make a chart, just like the other charts that we have back here, right? So we can start, we can go x plus 7, and 3 minus x here, as well as the result. Okay, we have those isolated. Now let's isolate our intervals up top. Okay. Now, I'll start with my lowest number. My lowest number is negative 7 here, so my first interval is going to go from negative infinity to negative 7. Okay, and it doesn't have to be a pretty chart, it just has to be effective. And then we're going to go from negative 7 to our next biggest number, which is 0. And then we're going to go from 0 to 3. And then we'll go from 3 to infinity. Okay. Now, let's see what we come up with on each of these. So what if we choose a number between negative infinity and negative 7 and see what it gives us on each of these? I'll choose negative 8. Let's see, negative 8 n for x just gives you a negative number. Negative 8 n for x plus 7 gives you a negative number. Negative 8 n for 3 minus x actually gives you a positive number. Negative times a negative is a positive, times a positive is a positive. So we wind up with an overall positive result. Okay. How about between negative 7 and 0? What if I choose negative 1? Negative 1 here would be a negative for x. Negative 1 here would be a positive for x plus 7. Negative 1 here would be a positive for 3 minus x. So here I wind up with a negative times a positive, which gives me a negative. How about between 0 and 3? How about if I just choose 1? If I chose 1 here, I'd have a positive number. If I chose 1 here for x plus 7, it'd give me a positive number. If I chose 1 here for 3 minus x, it would give me a positive number. Positive, positive, and positive is overall positive. And last but not least, I have to choose a number between 3 and infinity. I'm going to choose 4. If I choose 4 for x, it gives me a positive number. If I choose 4 for x plus 7, it gives me a positive number. If I choose 4 for 3 minus x, it gives me a negative number. Positive times a negative gives me a negative. And we have isolated our intervals here. Now, we want this to be less than 0, which means we want it to be negative. When does it work for negative? Well, it works for negative between negative 7 and 0 and 3 to infinity. Keep in mind it's not equal to 0, so we don't need to use brackets. We just need to use parentheses. So our final answer should look like negative 7, 0, and 3, infinity. We've isolated our intervals. Now, what happens if we have this same setup, but it's with a rational inequality? Well, we would need to get all terms on one side of the inequality and a 0 on the other. We would need to combine everything to a common denominator and then factor both the numerator and the denominator. And we would need to identify values that make the numerator or denominator equal to 0. And then we could, once again, use a table of signs to determine the desired intervals. Okay, let's give it a shot. All right, here we have the setup x plus 2 over x minus 3. We already have everything to one side and a 0 on the other side. Everything has a common denominator and everything's factored. So we've checked the first two things off the list. It's already set it up to be very nice for us. Okay. Now we need to identify values that make the numerator and the denominator equal to 0. Well, for the numerator, the value that would make it equal to 0, x plus 2 equals 0, would be x equals negative 2. And for the denominator, where we have x minus 3, the value that would make it equal to 0 would be x equals 3. Okay, so now we can set up our desired intervals here. We can go from negative infinity to negative 2, from negative 2 to 3, and from 3 to infinity. Okay, now let's check these values here. All right, I need a value less than negative 2. So between negative infinity and negative 2. If we chose negative 3, what would happen? If I chose negative 3, I'd wind up with a negative on the x plus 2. If I chose a negative 3, I'd also wind up with a negative on the x minus 3. A negative divided by a negative is a positive. Okay, now I need a value between negative 2 and 3. Let's say 0. If I plug 0 in here, I'd wind up with a positive and then a negative. A positive and a negative give me an overall negative. All right, I need to choose anything bigger than 3. Okay, maybe I choose 5. If I chose 5 here, the first value would give me a positive. The second value would also give me a positive. Positive and a positive is a positive. Well, here we are looking to be greater than or equal to 0. Now, this one's a little more tricky here, okay, because you have to think about it because it's a rational setup, okay? Now, we obviously know the two intervals that we want. We want from negative infinity to negative 2, and we want 3 to infinity, because those are the two positive intervals, which would make you greater than 0. But we also have this equal to part here. So it's okay if it's equal to 0. Well, which values make it equal 0? Well, technically, negative 2 would make the numerator equal to 0, which would make it equal to 0 overall. But 3 would make the denominator equal to 0. And remember, when we have a denominator equal to 0, that doesn't simplify to a 0. That simplifies to something we call undefined, right? So the only one that can actually equal 0 here is negative 2. So that's the one that needs the bracket on it. So our solution will be negative infinity to negative 2 with a bracket. And then 3 still with the parentheses because that value came from the denominator. We don't want the denominator to be 0 because then we wind up in an undefined situation. So we look at 3 to infinity, but with a parentheses on 3 because it can't equal to 3. All right. Now, what if we wanted to look at this graphically? Okay, I'm going to bring up the TI calculator for you real quick, okay? So, discard this. Bring up the calculator. We're looking at x plus 2 over x minus 3. So, y equals x plus 2 over x minus 3. Oops, need to put parentheses on that as well. Okay, I'm going to look at this on a standard zoom. Okay, this is what you're seeing here, right? Now, we want this to be positive, right? And what we determined was that from negative infinity to negative 2, it was positive. And if you look at it from negative infinity, it's above the x-axis, which would indicate positivity, all the way down to 2, where it actually equals 0, right? So we are positive here. Then when it gets to x equals 3, we do have some positivity over here, right? But you notice what happens at 3 is you have that vertical asymptote that we talked about earlier this semester, and that's why we couldn't let it equal 3, because that came from the denominator. But we do have positivity past that 3 point all the way to the infinity. So you can see that our intervals that we set up from negative infinity to equaling 2 are greater than or equal to 0, and from 3, not inclusive, all the way to infinity is also greater than or equal to 0. Okay? So you can see graphically now how that works. Let's get back to the PowerPoint. Okay. Let's try this one. This one's set up a little different. It says solve the inequality. X over x plus 1 is less than 3. Now, we need to get all terms to one side of the inequality and 0 on the other. All right, let's see if we can do this. Let me change my pen color back to blue. All right, now what I would need is an x over x plus 1 minus 3, and then that would be less than 0. I would just subtract the 3 over to the left-hand side. But the problem now is I need to combine it to a common denominator. Well, a common denominator here, 3 is technically over a 1, so the common denominator will be 1 times x plus 1, or essentially just x plus 1. What that would look like is x over x plus 1 minus 3 times x plus 1 over x plus 1 is less than 0. Okay. Now we need to combine it to a single denominator. So it would look like x minus 3 times x plus 1 all over x plus 1 is less than 0. Okay. And then let's simplify a bit. If we distributed, we'd have x minus 3x plus 3. Sorry, minus 3. Distribute that negative as well. All over x plus 1 is less than 0. And then x minus 3x would be minus 2x minus 3 all over x plus 1 is less than 0. Okay. Now, we want to use the table of signs to determine the desired intervals. What we need to do is identify the values that make the numerator and the denominator equal to 0. For the denominator, it's fairly simple. We're looking at x plus 1 equals 0, which would mean x equals negative 1 would make the denominator 0. For the numerator, negative 2x minus 3 would equal 0, which means that negative 2x would equal 3, which would mean that x equals negative 3/2. Okay, there's your other value. Now, we have our values isolated here. The smallest one is the negative 3/2. Okay. What we would need to do now is we'd need to write negative 2x minus 3 here. And we would need to write x plus 1 here. And then we would need to go and look at the interval from negative infinity to negative 3/2. from negative 3/2 to negative 1, and from negative 1 to infinity. Okay? All right. Now, let's start plugging in values. We need a value that's between negative infinity and negative 3/2. I'm just going to choose negative 2. If I plug in negative 2 here, I get negative 2 times negative 2 is positive 4. Positive 4 minus 3 gives me a positive number. If I plug in a negative 2 here, though, negative 2 plus 1 gives me a negative number. A positive number divided by a negative number gives me a negative number. Okay. Now let's choose a number between negative 3/2 and negative 1. Oof, this one might be a little bit harder. What if we chose, say, negative 1 1/4? Okay. We chose negative 1.25. If I chose negative 1.25, this one would wind up negative. And then you could always plug that in here too. This one would be a little bit more difficult to think about. The negative and a negative would give you a positive here. But, let's see. It wouldn't give you enough of a positive to overtake the negative there. So I think you wind up with a negative overall. So, yes. So this would wind up giving you, what's negative 2 times negative 1.5? That would give you, say, I think it's 2.5. Positive 2.5 minus 3. Yep, still winds up with a negative. Negative divided by a negative is a positive, though. Then I need a number between negative 1 and infinity. How about 0? 0 is nice. If I plug 0 into the first one, I get a negative number. If I plug 0 in the second one, I get a positive number. Negative divided by a positive is a negative. Okay, we have ourselves isolated here. Now, here's what I want to ask myself. Okay, now we want this. If we look at the final form that we found here, what makes this scenario less than 0? Okay, if this scenario less than 0 will be this scenario that's less than 3. Okay, now we want it less than 0, which means we want it negative. So it looks like our interval results here are going to be negative infinity to negative 3/2, and then negative 1 to infinity, right? Because we want it less than 0, which means we want it negative. Those are our two negative results. You can always check it on your calculator. I showed you how to do that in the previous example. And that concludes the lecture for today. If you have any questions, reach out by email. I'll give you homework a try. And I will see y'all next time.